Okay, so the double angle formula for sine is the sine of 2a is equal to 2 multiplied by the sine of a times the cosine of a. So if a were to say 4, sine, the double angle formula for the sine of 2 times 4 would be sine of 2 times 4 is equal to 2 times the sine of 4 times the cosine of 4. And that is roughly equal to 0.989 radians. And of course, you know 2 times 4 is 8. So when you plug in sine of 8 into the calculator, you will also get around 0.989 radians. All right. Now, the half angle formula for cosine. So the half angle formula for cosine is the cosine of a over 2 is equal to plus or minus the square roots of 1 plus the cosine of a over 2. So, say once again, if a was equal to 4, to just keep this simple, that would mean that the equation would be cosine of the cosine of 4 over 2 would be equal to plus or minus the square roots of 1 plus the cosine of 4 over 2. Now, if you plug that into a calculator, you get roughly plus or minus the 0.416. And first we're going to start off with a simple one. The sine squared of a plus the cosine squared of a is always equal to 1. A could be 4, a could equal 2, a could equal anything. And the sine of a squared plus the cosine of a squared will always equal 1. Next, we have the sine of A plus or minus B is equal to the sine of A times the cosine of B plus or minus the cosine of A and sine of B. Okay. So in this one, we have, let's have A equal 2 and B equal 4. So when you put this in the equation, it is the sine of 2 plus or minus 4 is equal to the sine of 2 times the cosine of 4 and plus or minus the cosine of 2 times the sine of 4. So how about we just start by multiplying these together. And so that would be sine 2 plus or minus 4 is equal to negative 0.59 plus or minus 0.31. Negative 5.9 plus 3.1 is equal to negative 0.28, and the sine of 6 is negative 0.28. Now I should note that this is all in radians. Yeah, there's our second trigonometric identity. All right, next we have the tan of A is equal to the sine of A over the cosine of A. So if A were to equal 4, the tangent of 4 is equal to the sine of 4 over the cosine of 4. And when you plug in both this equation and this equation on their own, you both get around 1.16 radians. All right, so that's another one. Up next we have cotangent. So the cotangent of A is equal to 1 over the tangent of A. Once again, if A equals 4, the cotangent of A is equal to 1 over the cotangent of 4 is equal to 1 over the tangent of 4. There we go. And when you plug that into a calculator, you get 0.86 radians. All right. What about cosecants? So the cosecant of A is equal to 1 over the sine of A. So once again, A equals 4, which means that the cosecant of A, or should I say 4, is equal to 1 over the sine of 4. Which when you plug that into a calculator, you get negative 1.32 radians. So that is the cosecant. But what about just ordinary secant? When it comes to secants, the secant of A is just equal to 1 over the cosine of A. So once again, A equals 4, which means that this is negative 1.53 radians. Around that. Next, cotangent. The cotangent of A is equal to cosine of A over sine of A. Notice that this is the opposite of tangent, where tangent of A was sine of A over cosine of A. So in cotangent, they flip like this. And so if like A is equal to 4, then the cotangent of 4 is equal to the cosine of 4 over the sine of 4, which is 0.86 radians. Next, there is cosine of 2a, and that can equal 2 times the cosine of a squared minus 1. Finally, the last two trigonometric identities are the cosine of a plus or minus b is equal to cosine a times cosine b minus or plus sine a times sine b. And there is tangent of a plus or minus b is equal to the, let me zoom in here, tangent of a plus or minus the tangent of b over 1 minus or plus the tangent of a over the tangent of b.